Hello, everybody. In Module 4, I discussed communication games between the managers and the market. Module 4 has 6 lessons. Today, we focus on Lesson 6, Bayesian persuasion models. In previous lessons, our focus is on exposed disclosure strategies, which means the manager is going to decide whether and what to disclose after observing signal realization. In this lesson, our focus is going to be on ex ante disclosure. The sender or the manager, they choose information structure ex ante, and they would commit to report whatever realization of the signal based on the information structure exposed. In my opinion, this makes it quite suitable to study mandatory accounting issues because the optimal information structure chosen ex ante can be interpreted as the optimal mandatory accounting rule chosen ex ante. The manager is the sender, the market is the receiver. The conflict of interest can be modeled as various agency problems. The discussion in this lesson is based on Kamenika and Jensko 2011 AER Bayesian persuasion, hence the name of the title of this lesson, Bayesian persuasion models. The general insight is as follows. Suppose the action is binary. A is either 0 or 1. The state is also binary. Theta is either H or L. The sender always prefers the receiver to choose A equals 1 regardless of state. But the receiver wants to match action with the state, which means choose A equals 1 when theta equals H, and A equals 0 when theta equals L. Because the action is binary, it is without loss of generality to assume a binary signal structure. So S can be either H or L. And the receiver is going to choose A equals 1 when observing S equals H. And it's going to choose A equals 0 when observing S equals L. From the sender's perspective, the optimal signal structure is as follows. When the receiver chooses A equals 0, the sender's least preferred action based on S equals L. S equals L is perfectly informative that theta is L. If the receiver chooses A equals 1, the sender's most preferred action, S equals H, is very uninformative, such that when observing S equals H, the receiver is indifferent between choosing A equals 1 and A equals 0. Golks and Wagenhofer J. 2009 also established this insight in a specific accounting setting. What does it mean? It means that the optimal information system from the sender's perspective is such that the bad news is more informative than good news, which means aggressive accounting in the sense of Gigler et al. 2009 JAR, if we interpret S as accounting signals. I'm not going to discuss accounting conservatism modeling in the series of videos. So if you want to learn more about that, check the Gigler et al. 2009 JAR paper. What is the intuition? The sender always prefers A equals 1, and the receiver is only going to choose A equals 1 when S equals H. So the sender wants to maximize the chance of getting S equals H. If you want to maximize the chance of getting some signal, that signal would become very common, which means the informativeness is going to be reduced. So if you want to maximize the chance of getting S equals H, you want to reduce the informativeness of getting S equals H. However, if the informativeness is too low, the receiver is not going to choose A equals 1 when observing S equals H. So you have to reduce your informativeness to the extent that when the receiver observes S equals H, the receiver is indifferent between choosing A equals 1 and the alternative A equals 0. Kamenika and Jensko builds on this insight and asks the following question in more general context. First, when will communicating information be strictly beneficial for the sender? And the second, if communication information is strictly beneficial to the sender, what is the optimal information structure from the sender's perspective? Let's use an example to illustrate the underlying insights. There's a prosecutor, which is the sender, and a judge, which is the receiver. The underlying states is either guilty or innocent. The prior probability that the defendant is guilty is mu0. The prosecutor is going to conduct the investigation, and the prosecutor has to commit how the investigation is conducted. How many witnesses to question? What kind of witness to question? What kind of evidence you need to show to the judge, etc. And eventually, the investigation is going to generate a binary signal that is either I or G. Because we have a binary action, so again, it is without loss of generality to focus on binary signals. The information structure can then be characterized as the probability of the signal being I or G conditional on the underlying state is guilty or innocent. The judge makes a binary decision, either acquit or convict. Acquit is denoted as 0, and convict is denoted as 1. Here are the payoff functions. The prosecutor prefers the judge to always convict. So the prosecutor's payoff will be 1 if there is conviction and 0 otherwise. For the judge wants to do the right thing. So the judge's payoff would be maximized equal to 1 if the defendant is guilty and the judge convicts, or if the defendant is innocent and the judge acquits. It will be 0 otherwise. First question: when can the prosecutor do strictly better off by providing an informative signal? The answer is, if mu0 is bigger than 0.5, you don't need to do that. And here is why. When you have a completely uninformative signal, or just no signal, the judge is going to rely on the prior in making decisions. When mu0 is bigger than 0.5, the prior that the defendant is guilty is higher than the prior that the defendant is innocent. The judge is going to choose to convict. In this case, the prosecutor's payoff is already being maximized. So the prosecutor cannot do better by communicating any information. Now, what if mu0 is smaller than 0.5, say mu0 is 0.3? In this case, if the signal is completely uninformative, the judge is going to choose to acquit because the prior probability that the defendant is innocent is higher, and the prosecutor's payoff will be 0. So there will be value from providing signal. If the prosecutor provides a completely informative signal, and the judge is going to choose a equals 1 with probably mu0, because with probably mu0, a completely informative signal is going to indicate to the judge that the defendant will be guilty. And the judge will choose a equals 0 with probability 1 minus mu0. The prosecutor's payoff will be mu0, which is bigger than 0. So the prosecutor is better off providing a completely informative signal versus a completely uninformative signal. Now the question is, can the prosecutor do better? Or equivalently, from the prosecutor's perspective, what is the optimal S? Is completely informative S optimal? And the answer is the prosecutor can do better by a not completely informative signal. And the optimal information system is as follows. Using Bayes' rule, that implies that conditional on the signal being I, the probability that the defendant is innocent is equal to 1. And of course, in this case, the judge is going to acquit. So that means S equals I is perfectly informative. Conditional on the signal being G, the probability that the defendant is innocent is going to be 1/2, which means that the judge is exactly indifferent between acquitting and convicting when observing signal equals G. That's exactly the general insight we discussed earlier. So in this case, we can calculate the prosecutor's expected payoff, which turns out to be bigger than the expected payoff when the prosecutor provides a completely informative signal. So in this case, prosecutor is better off when the signal is not completely informative. From this illustrative example, the Bayesian persuasion paper further characterizes the characteristics of the optimal information system. When the judge chooses the prosecutor's least preferred action equals 0, the judge knows for sure that the defendant is innocent. So when the judge chooses the least preferred action, the signal is completely informative. When the judge chooses the prosecutor's most preferred action, the judge is actually indifferent between convicting and acquitting the defendant. Those characteristics are also present in the more general settings. Algebra is going to be more complicated. Now let's talk about accounting applications. So I have a paper in management science which applies the insights from Bayesian persuasion into accounting setting. The manager is the sender, the investors are the receivers, and there's a binary action. Action is either liquidating the project or continuing the project. And here's the conflict of interest. The investors always want to make economically correct decision. You liquidate when the project expects the future cash flow is not big enough, is smaller than the liquidation value, and you continue otherwise. But the manager has a private benefit if the project is continued. So manager has an excessive incentive to continue the project. The social planner designs the information system to maximize investment efficiency. The manager and investor, they design the security based on the properties of the information system. And so this problem is a combination of ex-ante information system design by a social planner and ex-ante security design by the sender and the receiver. So it's slightly different from the typical Bayesian persuasion models when there is only information system design without security design. And we find that higher private benefits results in lower investment efficiency and also less conservative accounting. And here is the intuition. If the private benefit is higher, that means the manager is less likely to terminate. It's more likely to continue. So what you want is you want the bad news to be more informative to deter the manager from continuation. And bad news being more informative is less conservative accounting in the sense of Giggler et al. 2009 JAR paper. So one of our implications is that our results document a positive association between investment efficiency and conservative accounting, but there is no causal relationship. Investment efficiency being higher and accounting being more conservative, they're all driven by the extent of the agency problem. To conclude, the ex-ante commitment of Bayesian persuasion is, in my opinion, a natural way of modeling accounting rules. So far, the information system has been mostly constrained to binary signals because of binary actions. And this is due to tractability. And so far, the focus has been on conservatism, which is essentially whether good or bad news is more informative given the binary signals. In my opinion, new insights can be obtained by relaxing the binary action framework and by looking at the properties of optimal accounting systems beyond conservatism. And I have a JE paper which makes an attempt in this direction. If you're interested in testing your understanding of this lesson, a review quiz of this lesson can be found at the link provided in the slides. Thank you very much.